Have you ever wondered how companies decide which features to include in a new product? Like your favorite drink is whether naturally flavored, has electrolytes, or has an eco friendly packaging. That's where conjoint analysis comes in. Hello, my name is Sonima, and I'm a graduate student at the Webster University. Today, I'll be guiding you on the topic of conjoint analysis. To begin with, conjoint analysis is a market research method that helps businesses understand how customers value features of a product or service. Instead of asking people directly what they like, conjoint analysis lets us infer their preferences by analyzing the choices they make between different product combinations. In a conjoint study, we combine product attributes like price, color, brand, or delivery to different product profiles. Respondents rank or rate these profiles, and from that data, we estimate how important each feature is. It is widely used in marketing, product design, pricing strategy, and even by tech companies when testing new features. In this video, I will show you how conjoint analysis works step by step using real data. Now that we understand what conjoint analysis is, let's go ahead and see how it actually works in Excel. Here we have a fictional apparel company, ABC Apparel, which is interested in adding tumblers to its product portfolio and has a number of options available. However, ABC has a desire to limit offerings to those that will be the most desirable and has hired you to determine which tumbler combination would be the most attractive. ABC has limited the attributes to ones which provide targeted price points and profit margins. So our first step in doing our conjoint analysis is to understand the data. Here we have our data table. Each row represents a unique product profile and a different combination of attributes. The last column, rank, shows the average ranking of each combination, where 1 means it is the most preferred. The other column shows product attributes like design, brand, price, color, and thermal insulation. So our next step is to conduct the code the attributes into dummy variables. Because conjoint analysis uses regression, we need to convert these categorical features into numerical values. This process is also called dummy coding. But in this, we need to make sure to drop one level per attribute so that our model runs smoothly. In other words, we are leaving a baseline out. For example, for the attribute design, we are creating separate columns for each level A, B. For brand, we are creating 1, 2. In design, we have left C as a baseline out. In brand, we have left 3 as our baseline, and similarly on other attributes as well. So to determine the dummy variable for design A, we are using if function. If this cell is equals to A, and we're gonna lock this cell, then we are getting 1 as a value, else 0. We are gonna copy and drag it down, and we have our values. We are going to do the same with all the other attributes till thermal insulation. So now we have our dummy variables over here, and the other step is to calculate our rank reversal. Our formula is max, and we're going to select this array and lock it minus this plus 1. We're going to use the same formula, copy and drag it down. There you go. Just check your formulas just in case. Yeah, it's correct. So now that we have determined our dummy variables and our rank reversal, The next step is to run the regression. We need to categorize our data into X range and Y range. Our rank reversal is our Y range, and the other dummy variables are our X range. Next, we use the data analysis ToolPak to run multiple regression. The dependent variable is rank and the independent variable is our dummy variables. I'm taking the levels, confidence level, and then the output range would be here. It's good. Once we run the regression, Excel gives us an output table showing coefficients for all our dummy coded columns. We can see it right here. So our next step is to interpret the coefficients. I have created a table over here where we can interpret the coefficients, range, and our level of significance. I will just copy my coefficients from the regression table to this new table, and the coefficients for our baselines would be 0. So here we have our coefficients. Now we will be calculating the range. The formula to calculate the range is max this array minus the minimum of the same one. And right below the range, we need to do a sum of range as well, sum of the whole array, which will be useful in determining the level of significance. Here, our next step is calculating the level of significance. To understand which attributes matter the most overall, we calculate the range for each attribute and then the difference between the highest and lowest utilities, and then we find the relative importance by dividing each range by the sum of range, which tells us which attributes are the biggest driver of customer choice. So the level of significance is equal to range divided by the sum of range. So here we have our sum of level of significance, range, and everything, from which we can determine which attribute is the most significant for the customers. Completed our conjoint analysis, we have to interpret our results. From the level of significance, we can see that design of the tumblers is the most valuable features for the customer with a 0.33 level of significance, followed by the price with 0.32 level of significance, whereas the color of the tumblers matters the least to the customers with 0.06 level of significance. In terms of design, design A is the least preferred design with minus 4.5 coefficient, whereas our baseline C is the most preferred attribute. Check if our experimental design is orthogonal, which means that the attributes are statistically independent. We can test this by calculating the correlation matrix among the dummy coded variables. If all our correlations are close to 0, our design is orthogonal, meaning each attribute varies independently and our results are statistically valid. Correlation matrix, we are going to select our attributes and we are going to use our data analysis ToolPak, scrolling up to correlation, and this is our, we're gonna check the range. This is our range. We have levels checked out and the output range should be, I guess, over here. And okay. And here is our correlation matrix. A correlation matrix of our coded attributes for the conjoint design. Orthogonality is a key in conjoint analysis, as it ensures each attribute's effect on the choice can be measured independently. Here, looking at our table, the diagonal entries are 1, which is a perfect correlation by themselves. And the off-diagonal entries are, most of them are 0 or very small numbers like this or this over here. These values are essentially zeros. So we can say that our matrix is essentially orthogonal. This means that each attribute level varies independently to the others. When we estimate the part worth utilities, no multicollinearity will bias the results. And that's how we perform a conjoint analysis in Excel, from data setup to interpreting the results. If you found this video helpful, don't forget to like, subscribe, and comment below what kind of data analysis tutorials you'd like to see next. And thank you for watching.